Module 4, remember, is on percent and proportional relationships. So in lesson 4.1, we talked about what percents are and converting them, maybe between decimals and fractions. And now we're going to talk about part of a whole as a percent. Okay, so remember, we said percent is a part out of 100. Okay, so we're going to kind of take it to the next step and we're going to say, you know what, it's part of a whole. That whole doesn't need to be 100, but we're going to change it to out of 100 to make it a percent. So first we need to be familiar with what part and whole means. So it says, what is the whole unit in each of these scenarios? Okay, percent is part out of 100. So we need to have, when we're going to convert to a percent, we need to know what our whole or our total is. So 15 is what percent of 90? Okay, so looking at this, we have kind of three things going on here. We have 15, we have percent, and we have 90. Which one would represent like the total or the whole thing we're taking a part out of? That's going to be 90. What percent out of 90? Now it says what number is 10% of 56? Okay, so we can find our percents right away, and I'm going to talk in a little bit about how that's important. We want to be able to find our percent. So we're taking what number is that 10% out of 56? Can I start getting to see here? Okay, our total is always going to be, we're taking something out of it. So our whole here is 56. So again, 90% of a number is 180. Okay, so 90% out of a number, or of a number, is 180. 180 out of a number is 90%. So in this case, it's an unknown number. An unknown number. Spell it right here. Unknown number. That's an E. Okay. So you can see here that we're going to have basically three parts every time we're doing this. It says a bag of candy contains 300 pieces and 25% of the pieces are red. Okay, so we have the pieces that are red. So if we want the whole, how many total pieces are there? 300. 70% of the students earned a B. So there's a percentage of students, 70, that earned a B. How many total students were there? Well, that's what we have here. All the students is our whole unit. All of them, okay? The students here, but we're talking about all the students, and 70% of them got a B. So that whatever that number is, okay, is out of the total number of students. 20 girls in the class represent 55% of the students in the class. So again, we have a total number of students. So we're going to say all the students, or all the class. Maybe I'll say to make things a little different, right, from the last one. And I'm going to try to write class a little bit nicer so it actually looks like class. Okay, so again, that's picking out the whole unit. And we've kind of noticed how we really have three parts to these. So now let's focus on those three parts. Read each problem and complete the table to record what you know. We have part, percent, whole. Here is my hint. The easiest one to pull out is this percent. Why? Because guess what percents are going to have? They're going to have a percent sign. Okay, so if I read this problem, it says 40% of the students on the field trip love the museum. If there are 20 students on the field trip, how many love the museum? Well, we're going to have a part, a whole, and a percent. Percent is going to have the percent sign. So I'm going to pull that out first. Okay, and now I only have to figure out the part and the whole. I can't really tell you which one's easier. It depends on the problem. But if I look at this, I'm going to try to figure out, well, we're talking about students on a field trip. So do I know the total number of students on the field trip? 40% of them love the museum. There are 20 students on the field trip. Great. That's our whole. Do I know the part? Now I know we have 40% of the students, but that's not the number of students. So in this case, we don't know what the part is, okay? And that's what we're going to be getting into here, is how we can figure this part out. But before we can figure it out, we need to be able to identify our pieces. So another similar problem in the next one. 40% of the students on the field trip love the museum. If 20 students love the museum, how many are on the field trip? Pull out the percent. We still have the 40%. Now, do I know the total number of students? In this case, they're telling us how many love the museum. 40% of the students love the museum. There are 20 students who love the museum. So I don't know the whole, but I know that the part out of them, 20 out of the total number, which represents 40%, love the museum. And finally, 20 students love the museum. There are 40 students on the trip. What percent? So in this case, we don't know the percent. Do I know the whole, the total number of students on the trip? Sure do. 40 students. And what part is that? 20. Okay, so being able to figure this out, like what the part, the whole, and the percent are going to help you solving for the one that you don't know. And speaking of solving, let's do that. A visual approach to finding a part when we're given a percent of the whole. Okay, so in Ty's math class, 20% of the students earned an A. There are 30 students in the class. So obviously this is the percent. If there's 30 students in the class, that's the whole, right? That's the total number of students. So let's think back to tape diagrams. Okay? This whole thing here is going to represent all 30 students. Okay? Still struggling with the whole writing thing, sorry. Students, and then that didn't get any better, sorry. Okay, now, if we're talking about all the students, I want us to think what percent represents every single one. 100%, right? This represents 100% of the students, but we only want to worry about what 20% is. So we want, if we have 20%, let's take this 100 and let's break it up into 5. Why? Because 100 divided by 20, if you remember back to tape diagrams, and this is just a visual example, we're not going to do the problems necessarily like this, although you could, equals 5 groups, right? So if we're breaking 100% into 5 groups, because each one of these is going to represent 20%, then I want to figure out what number goes into each of these. Well, if we have 30 students, if I take 30 students and divide them up by 5, I get 6. That means there is 6 students for every 20%. So I want to know basically what is 20% of 30 students. And we basically have that right here, don't we? Okay. Now, 6 students. All right, so six students got an A. I want to start thinking, because in the next video we'll start doing more of an equation. But remember, we can take 20%. And I told you we can't really do much with percents. It's great, but we can't multiply or divide by percents. We have to change it into a decimal. So if I move it 2 places left and drop the percent sign, that's 0.20 or 0.2 or 20 hundredths. Of means to multiply. So if you were to take a calculator and go 0.2 times 30, guess what it also equals? 6 students. Okay. So here's the visual. Here's what we're going to actually do as an equation. Let's look at one more quick example. So in Ty's art class, 12% of the Flag Day art projects received a perfect score. There were 25 projects turned in. Okay, so the whole is 25, and we want to figure out what 20% of that is. So real quick, let's do a tape diagram. Okay, and again, this represents 100% or 25 projects. So if I want to know what 12% of those are, what I would do is I would take 100% and I divide it by 12, and I tell you I'm going to get like 8.3 repeating. So I don't want to make 8.3 repeating blocks, but let's just say that each one of the box that I put in here represents 12%, right? And then let's use kind of the second method here, because that's the problem with tape diagrams. It's not always going to work out perfect. So remember, to figure this out, I basically just took the total number of students and divided by how many squares there were. I don't know how many squares are out here. 8.3 repeating, not going to work. So think of it this way. Think of the fact that we want to take 12% of 25 projects. And I can take 12% and I can make it into a decimal. Okay, and I end up with 0.112. Of means to multiply, and then 25. So if I grab my calculator and I go 0.12 times 25, I get 3. Okay, that equals 3. So what are we talking about here? 12% of the art project received a perfect score. 3 projects received a perfect score. So tape diagrams aren't going to always work for us. So in the next video, you're going to see how we can use this idea of part, percent, and whole to set up equations.